So, hello everyone. I hope you guys are doing fine, and I welcome you all in my this class. This is the third class of class 9 physical sciences, and I welcome you all in this class. So, as from my previous class, you might be knowing that we studied about gravitation. We saw what are the importance of gravitation, right? And we also modified the equations of motion for the sake of including the gravitation. We saw how the equations of motion change for a freely falling body and also for a body that is thrown upwards, right? So we saw those things. So in our today's class, let's begin by showing a picture. So students, you can observe here, there are two pictures, picture A and picture B. So students, tell me, what does the picture A represents to you? Yes, the picture A represents the physical balance, right? And this picture B, it represents the spring balance. Okay, right? And what it measures? This measures something else. It measures something known as mass, and this spring balance measures something known as weight. Right, students? This is the difference. The physical balance measures what? The physical balance measures the mass, and the spring balance measures the weight. Okay, students. Now let's see what are the difference between these two things. That is the difference between the mass and the weight. Okay, students. Now let's see what are the difference. So the very first difference is that mass is a scalar quantity, right? So mass is a scalar quantity, but weight is a vector quantity, right? So if we say that mass is a scalar quantity, what I mean that mass is having only magnitude, but it is not having any type of directions to it, right? But in the case of weight, it is having magnitude also, and it is having direction also. So that's why we say that weight is a vector quantity, right, students? So mass of a rigid body is regular everywhere in this universe, right? So suppose that this phone weighs 500 grams. Okay, so this phone which weighs 200 grams or 300 grams, 400 grams or 500 grams, take any number you guess. So this phone will measure 200 grams no matter where you put it. You put it on the sun, you put it on the moon, you put it on the Jupiter, you put it on the Venus, you put it on any object, right? So the mass of this phone will be 200 grams, right? But the weight of the object, then when we say the weight of this body, it will change, right? It will be changing from the earth. Suppose that if this phone measures 360 grams on earth, right? It measures 360 newtons on the earth. Then how much it will weigh on the moon? It will weigh 60 newtons on the moon. Okay, students, right? So the weight of the rigid body alters from place to place, right? It alters from place to place and inclines to zero at the center of the earth, right, students? So mass can be measured. Mass can be measured by what? Mass can be measured by a traditional balance or a physical balance, okay? And weight can be measured by spring balance, okay? So mass is measured by traditional balance and weight is measured by spring balance. Right. So what is the unit of mass? The unit of mass is kilogram or gram, and the unit of weight is Newton. Right. The unit of weight is Newton. Right. So mass can never be zero. Okay. So mass is basically the quantity of matter contained inside an object. Right. So there cannot be zero quantity of matter contained inside an object. So mass can never be zero. Okay. But weight can be zero because it is the product of mass times gravity. We will look it in our next slide. So weight can be zero. Right. So mass does not change based upon the location. Suppose that if I am living at the equator of the earth and I go to the poles, then what should happen? What will happen to the weight? My weight will increase, isn't it? My weight will increase because at the poles the gravity is more, right? But my mass will be same. My mass will be exactly the same, right? So mass is measured by what? The mass is measured by ordinary weighing scale, right? And the weight is measured by the spring balance. Okay, right. So students, now there has to be some relation between the mass and the weight. Okay students, so this is the relation. When we say weight, it is actually the force. Okay, weight is actually the force which is equals to the mass times acceleration due to gravity. So we can say weight is equals to mass times acceleration due to gravity, right? Okay students, right. Now let's take an example. Suppose that in which case weight will be more, at the poles or at the equator? Tell me students. Yes? Okay. So at the poles, let's write it as mass times gravity at the poles, and for equator, let's write it mass times gravity at the equator, right? So we know that gravity at the poles is stronger than gravity at the equator. So we can say that what weight at the poles will be more than the weight at the equator. Understood students? Is this point clear to everyone? Okay. Now let's proceed forward. Okay students? Right. So there is a quiz for you. So the first question is, there is always a variation seen in mass rather than weight. Okay. There is always a variation seen in mass rather than weight. Is this statement true or false? You need to give reason also. Okay students? Okay, right. I'm giving you 10 seconds to quickly think about it. Then I will ask you the answer. Okay, right. So the answer is, this statement is false, isn't it? There should be no variation in the mass, but there can be variation in the weight, right? Because mass times gravity, this equals to weight. So therefore we can say that there will be never any variation in the mass, but there will be variation in the weight. Okay. So now there is another question. The question is, which is the correct weight? Okay, which is correct for weight? Okay, so the question is, which is correct for the weight? First option is, it can be 0. Is this statement true or false? You need to see that if it has direction, weight has direction, it can be measured by a physical balance, both A or B. Which of these statements is correct? Okay, about weight. Right. I'm giving you again 10 seconds to quickly think about it. Then I will ask the answer. Yes, students? Right. So both A and B are the correct. So mass can be 0 because gravity can be 0 sometimes, and also it has direction, right? But it is always measured by spring balance, right? It cannot be measured by physical balance. We measure mass by the physical balance. Okay, students? Right? Now let's proceed. Let's look at this picture, students. In this picture, what are you observing? Here is an astronaut, and this astronaut is like moving in this atmosphere, rotating everywhere like he's weightless, he's not having any weight. Why is he so like rotating in this atmosphere like he has no weight? Is there something related to gravity or gravitation? What do you think? Okay, right? Then I will just give you a hint of it. So let's write the equation, Newton's law of motion. Okay, Newton's law of motion and Newton's law of gravitation. So according to the Newton's law of gravitation, we write F equals to what? F equals to G m m by r squared, right? So this is the equation that we are writing. F equals to G m m by r squared, right students? Okay. So here M is what? M is weight of the bigger body, and small m is the weight of the small body, and r is the distance or the separation between them. Okay students? Right. Right. Now we will do a fun activity where we will calculate our weight on earth, our weight on moon. So let's take our mass as m on earth, right? And the mass will remain same everywhere. So on the moon also, the mass will remain as m kgs, right? So the force of gravity on earth will be mass into acceleration due to gravity. Okay, and the force of gravity on the moon will be also force into mass into acceleration, right? So the force of gravity on earth, this will be your mass, that is m times 9.8, and on the moon also it will be m times 1.6 meter per second square. So now let's divide it. Okay, let's write f g, force of gravity on moon. Okay, force of gravity on moon, this equals to what? Force of gravity upon moon, this equals to m times 1.6, right? And force of gravity on earth, this equals to m into 9.8, right? So when we will divide it, we will get a ratio of 1 by 6. This means that if your weight is 60 kgs on earth, then it will be 60 into 1 by 6, this equals to 10 kgs on moon. Okay students, this will be 10 kgs on the moon, right? So weight of the body on the moon will be 10 kg if its weight on earth is 60 kg. Okay students, understood this point? Yes, right. So now let's proceed forward. So is there any reason why your weight on moon is 1 by 6 of that on earth? Is there some reason to it? What might be the reason? Just try to think about it. What might be the reason? Okay, right. So the reason is what? The reason is very simple, and that reason is what? That reason is gravitation, or the forces of the gravitation, right? So it is F equals to, I'll write it here, F equals to mass into acceleration. So in the case of weight, right, it will be equals to mass into acceleration due to gravity. So this component, acceleration due to gravity, changes on moon and on earth. So acceleration due to gravity on earth, right, it is 6 times that of acceleration due to gravity on moon. So that is the reason why an object weighs only 1 by 6 of its weight on moon. Okay students, right? So now let's proceed further. So students, have you observed what is shown in this picture? Have you ever seen in your real life? Yes, right. So this is a lift, right? This is a lift. And what lift does? A lift carries people from a lower ground to a higher ground, or lower floor to a higher floor. Okay students, lift carries people from the lower floor to the higher floors. Okay, very good. Now have you ever wondered why when we are traveling in a lift, sometimes we feel that our weight has become a little bit less, and sometimes it feels whenever the lift starts, we feel like yes, it has started now, our weight is like a little bit more. So have you ever felt that? Yes? Okay. Okay students, now just look at these pictures, right? What you can see from this picture. Okay, in the first picture, it is shown that the girl is having a normal weight. When the lift is moving upwards in the second picture, the weight of the girl increases, right? And when the lift is moving downwards with some acceleration, the weight of the girl is less, right? And if by chance the lift breaks and it freely falls, then the weight of the girl becomes zero. So why it is so, students? Let's see this answer. Okay, so upon moving up, what we feel more weight, and the weight is due to the reaction force, right? This is due to the reaction force applied by the surface of the body, right? So the force that we are experiencing is ma minus mg. Ma is what? Ma is mass into acceleration due to gravity of the lift. Okay, and g is what? Acceleration due to gravity, right? So the force experience will be what? It will be ma times ma minus mg, right? Okay, so now when we see that the value of A is increasing, right? When the value of A is increasing, then what is happening? We feel more weight, okay, right? When the value of A is decreasing, we feel less weight. And suppose that if the, let's write this equation some little bit, so we can write F equals to m times a minus g, right? So we can see as the value of a will increase, as because the g is constant, okay? G is always constant here because we are talking about only on the earth, right? So g is constant. So as the value of a will increase, the force will increase, or we can say our weight will increase, right? But when the value of a will decrease, then the weight will decrease. So suppose that now this a becomes g, right? So g minus g is 0, right? So in this case force will be what? Force will be m times 0. This will be 0. That's why the weight of this girl falling free in a free falling lift will be equal to 0, and she will be facing a situation that is called as what? That is called as weightlessness. Okay students, that is called as weightlessness. Okay, now let's proceed. So now students, we have reached for a quiz again. So the question here is, what will be the weight when the lift is going with a constant velocity, right? What will be the weight when the lift is going with a constant velocity, right? Let's solve this question. Let's solve this equation. So we know that, okay, let me change the color of the ink, right? So we know that F equals to mass times A minus G, isn't it? F equals to m times A minus G. So since it is going with a constant velocity, so this acceleration is not changing, and this acceleration is equal to the gravity, right? So there will be no change in the apparent weight, and the person will feel nothing, and his weight will remain the same, right? The weight remain the same, right? So now let's move towards the next question, next thing, okay? So what we have studied in our today's class, students? In our today's class, we have studied about mass and weight, okay? So now let's quickly answer a few questions, okay? So let's differentiate between mass and the weight. So first of all, mass is a scalar quantity, weight is a vector quantity, right? Mass is measured by physical balance, weight is measured by spring balance. The value of mass will never change, not on the earth, not on any other planet, but the value of weight will change, right? Okay, so now we need to compare the weight on earth and on the moon. So the weight on the moon will be 1 by 6 that of on the earth, right? So why do we feel the weight less in the lift that is moving downward? Less weight when the lift is moving downward, right? We feel less weight because the apparent weight is getting reduced. We know this equation that F equals to m times A minus G, right? So since this acceleration due to gravity is getting decreased, so that's why we feel less weight, okay? Right. So explain why we feel more weight if the lift is moving upwards. If the lift is moving upwards, then what is happening? This acceleration due to gravity is the constant, but the acceleration of the lift is increasing. That's why we are facing more weight. Okay, right. So in the case of free fall, what will happen? The value of A will become the value of G. So in this case, what will happen? M times 0. So it will be 0. So they will be feeling what? They will be feeling weightlessness. Okay, students? So that is all for our today's class. So now let's come to the homework section. So in the homework section, you need to compare your own weight on different planets like Mars and Jupiter. Okay, and for that I am giving you a little bit of hint, and that hint is that you will need to find the acceleration due to gravity on those planets. Okay, students, right? Yes. Is there any problem in our today's class, or everything is clear? Okay. So now I will be ending our today's class, and we will be meeting on our next session very soon. So thank you students once again. I thank you all for attending this class. Please do consider liking and subscribing if you find this video lecture interesting. Okay students. Bye. Take care.